There's a homework problem.
No. I never do that.
Okay, does anybody remember anything we learned yesterday? What did we learn yesterday? The law of signs, yes indeed. And so let's, just as a warm-up, since nobody had any issues apparently, let's take a look. And let's suppose that I ask you to find side C. Okay? Can anybody set this up for me, Dan?
I will first need to find the angle of H.
Alright, and you want to find that for me?
49.
He did that with no calculator, is he right? How do we find that third angle? Subtract these two from 180. Okay, now what, Dan?
And then you will use sine 49 over 10 equals sine 50 over C.
Beautiful. And then we show as much work as we need to show in terms of cross multiplying and dividing to come up with our answer. And we type it in on our calculator, we round it off however the directions tell us to round it off. We've just been doing it to the 100th, just randomly. You'll just want to follow directions. And I got 11.24. Anybody want to confirm that for me? Did I make a mistake or we good? Okay. So everything's cool with the law of signs. Two things that I want to remind you of before we move on then. One is that the law of signs is going to be your method of choice whenever you have a pair of information. And by a pair, I mean, I know the angle and its corresponding side. If you have that information, you are going to use the law of signs. The law of signs is the easiest law, so we always want to default to that if we can. There is one issue with the law of signs. Does anybody remember what that is? It wasn't a factor here, but it is sometimes. Anybody remember from yesterday? If you set your law up and it looks like this, I'm making these numbers up, then you got a potential problem, right? Because when do our little antenna go up? Whenever we have the law of signs, but our variable is the angle. This means that when I solve it, when I'm getting all done, I'm going to have to do second sine, inverse sine, arc sine. And there are two possible answers to that question. So if I do this out, and I do inverse sine, and it comes up, let's say 35 degrees, then I know another possibility that I have to check is 180 minus 35. Is this ringing a bell from yesterday? Okay. All right, then what I want to do today is ask you about this triangle.
Are we still doing law of signs?
Well, we're going to see. Let's take a look at this triangle. Now let's suppose your job is to solve that triangle. Can you SOHCAHTOA? No. Can you Pythagorean theorem?
Should you draw an amplitude?
No. I'm going to try this without drawing any auxiliary pieces. Can I use my law of signs? No. Why not?
Because you have to find two things if you do.
I don't have a pair. And it isn't that I can't set it up. I can set it up, but look what happens. Sine 58 over A equals sine C over 13. See what happens? Too many variables. I have to have a pair. So, if I have a situation where the law of sines doesn't work, I'm going to use the law of cosines. Okay? Now, the cosine law looks way more complicated than it is. So I'm not going to write the formula first. I'm going to work this problem out and have you kind of discover what numbers go where and how it all works. All right, so here we go. The law of cosines for this situation is going to look like this. A squared equals 12 squared plus 13 squared minus 2 times 12 times 13 times cosine 58. Now, I know great fear has just entered your heart. Okay? Do not panic. You're going to be using this by the end of the period. You're going to be using it like this. What's important is that you kind of pay attention to what's going on there, what numbers go where. Notice that how many angles are necessary for the law of cosines? One. And notice, in our case, it's angle A, right? Angle A. Notice that this is A squared. So if this had been angle B, then this would be B squared. So whatever angle you're using in the law of cosines is the letter that's over here all by itself. All right? Now, notice everything else in the problem. Okay, you got angle A and side A. Everything else in the problem is a combination of what? The other two sides. And order doesn't matter. So I've got side squared plus side squared minus 2 side. Okay? So I'm going to come back to this in a minute. If I were going to write out, let me use different letters. If I were going to write out the law of cosines using angle X, if I'm going to use angle X, I need one angle in the law of cosines. It would be X squared equals what?
Y squared plus Z squared minus 2y Z cosine. Is there an angle I can see? Cosine X.
That is it. See? 3 minutes and you got the pattern down. That's all there is to it. Whatever angle you're going to use, and you need one, whatever angle you're going to use, that's the side that's over here by itself. That's your angle. And then everything else is just the other two sides, x or y squared plus z squared minus 2yz cosine x. Okay? Easy. Now, let's come back to our problem. This, you can just type in. You don't have to do anything fancy. Just type in exactly what you see. 12 squared plus 13 squared minus 2 times 12 times 13 times cosine. Remember, we're doing all cosines now, so we're using cosine 58. Tell me what you get. Just type in that long string of stuff. 147 point something. Now, be careful. That is not A. That's A squared. So once you get that number typed in, you have to do what with it? Square root it. So side A is actually 12.15 after you square root it. Does that make sense to everybody? So I have used my law of cosines to find side A. But I'm not done. My job was to solve the triangle.
Oh, we gotta find the angles.
Now I gotta find the angles. But now, kids, look at what you have. Now we can do the law of sines. Okay? Everybody clear on that? We could also do the law of cosines, but that's gonna be way harder. So I'm just gonna go ahead and use my law of sines. So sine 58 over 12.15 equals sine B over 12. Anybody's antenna going up?
You can find an angle.
Yeah, but here's the good news. Just something else you have to remember. You only have that issue with the law of sines when it's step 1 in the problem. If it's step 2 of the problem, you don't have to worry about it. So I don't have my antenna. My antenna are not up. I do not have to worry about it. This is normally a situation that would cause me trouble, but I didn't start with this. I started with this. So I'm good. From that point on, I'm good. So I'm not worried about it. I'm going to type it in. I'm going to get my answer. Everything is going to be great. Did you get 56.89? Can someone give me confirmation?
Yeah.
Okay, good. And then what do I do to get angle C?
He's got added 180.
Well, yeah, add them up, subtract from 180.
Yeah.
Did you get 65.11?
Good.
Everybody okay with that? Alright. Let's try this. That's a little side triangle from geometry. Your job is to solve it. Which I guess in this case means find all of the angles. Alright, what's your thought?
Solve the cosine.
Okay, law of sines or law of cosines? Which one?
Cosines.
Gotta be cosines. Because why?
We don't have
Cosine.
We do not have a pair of information. It isn't that the law of sines isn't true. It's true. It just has too many variables in it for you to solve. So which angle do you want to find?
With P.
Okay. Now, like sometimes on tests and quizzes, it will say find the smallest angle or find the biggest angle. Would you be able to tell which one was the smallest and the biggest from this given? How do you know?
It's the opposite from the side.
So which one would be the smallest?
R.
R. Which one would be the biggest?
Q.
Q. Now, Dan said let's find P. I'm fine with finding P. But we need to remember, we just need to know if the directions say find this particular one, we need to know how to find it. Everybody clear? Alright, so if we're going to find angle P, then which side is going to be over here all by itself squared? 11 squared. And then out here is going to be cosine P, right? Now there's nothing special about P except Dan picked it. We could be doing this with R or Q, it doesn't matter. Alright, what's going to go here then? 10 squared plus
12 squared.
12 squared minus 2, 10, 12. Now this is a little harder to type in. I need you to be careful. It is not hard, but you do need to pay attention. 11 squared is 121. Everybody agree with that? 10 squared plus 12 squared
244.
is 244. And 2 times 10 times 12
240.
is 240. Now notice, I am not combining the 244 and the 240. Because the 240 is hooked to a cosine. Those are not combinable. So if you're going to solve, I guess your next step is going to be to move this over here. So what is that? Negative 123. I'm doing this without a calculator, so please keep it on my arithmetic.
It's divide.
And now I'll divide. Yep. So I'll have 123 over 240 equal to cosine P.
Indeed.
Uh, 59.17.
Now we can use the logs.
We okay with that?
Wait.
Now, you get to pick. Could you repeat the process for angle R?
Yes.
But you could also do what now that you have this?
Logs.
Now you could do your law of sines. So whichever one flips your switch. Yeah, Kayla?
I got a decimal. Yeah.
For this number?
Yeah.
Okay, remember, that's the cosine.
So to do that.
So now you have to inverse cosine.
Okay.
Yeah. Okay, now, would everybody go ahead and finish the triangle? Either way, I want everybody to finish it, find the other angles, either by repeating the law of cosines, which is absolutely fine, or doing the law of sines now that you have a pair. I put my answers up here so you can double check those. Let me know if we match. Anybody matching mine? Okay. All right, we're going to practice one more problem because on Monday when you come in, I'm going to give you a triangle and I'm going to say solve it, okay? So let's pretend that this is your quiz. And I want you to solve that triangle, which means you're going to find side B, angle A, and angle C. Right? Let's give it a shot. Anybody feel like you can come up and put it on the board? Put your work on the board. Okay, Victoria, awesome.
Already?
Well, she's just going to do it up here.
Uh,
She just feels confident that she can do it. Calculator in hand, awesome. You are going to struggle without a calculator. Please make sure you have it.
guess I can't see it from here. Yeah, have one.
Well, if I were grading her paper, I'd give her 100%. What is it? Anybody done? Anybody this far yet? Thank you, Victoria. Nicely done. Who has a question? Okay, are you typing 16 squared plus 18 squared minus 2 times 16 times 18 times cosine 47 equals? Type it straight in. And as soon as you hit equals, then you're going to have to square root, remember, because that's going to be b squared. These are easier, Jamie, if you don't break them up. Just type it straight in. Your variable is already over here by itself, so there's no reason to do it in pieces. Just you get it? Anybody else? Once in a while, depending on the order you do things, because let's see, Victoria chose to find angle C. You could have found A first. And once in a while, depending on the order you do things, you might be off by 1/100th. And that's okay. I'll see your work. I'll pay attention to that. We should never be off more than that. okay? All right, so everybody understands Monday you're gonna have to do this, right? We're all good. All right, now then, we're gonna take this to the next level. In fact, I'm gonna use Victoria's problem. We're gonna find the area of triangle ABC. Right here, we're gonna use Victoria's problem. Okay? Now, at this point in your life, you may only have one way to find the area of a triangle. There are actually like 15 ways. But you may only know one at this point. What is that? 1/2 base times height. Now, we have a little bit of an issue here because we don't know the height. But if you think about what we talked about yesterday, now that Victoria has done all this work, we can find the height. What kind of triangle is this one right here?
Right.
So can I say that the sine of 74.2 is h over 16? So h would be 16 sine 74.2? All right, we can figure that out then, can't we? I got 15.4 basically. So now we can do the area of our triangle. You said area was 1/2. The base, which would be what? 13.68 times the height, which we just found to be 15.40. And I got 105.336. What about you? Did I type that in right?
Yeah.
Now, that wasn't bad at all, was it? Well, it wasn't bad at all, given that Victoria had already done all that work. I want you to look at what we started with. What we started with was this, right?
Yep.
Everything else we needed, Victoria had to find, which she did, and it was all good, but that's a lot of work. Not to mention, is there any round-off error in this answer? Yeah. I want you to type this in. Just type that set of numbers in on your calculator. This is the area with no round-off error. This is the area of this triangle. I have just given you a wonderful piece of information. In addition to 1/2 base times height, you have a new area formula. 1/2 side times side times sine of included angle. Now, what do we mean by included angle? The one in between. So let's look at the scenario. I have two sides and the angle between them. The area will always be 1/2 side, side, sine of included angle.
Wait, does it have to
Ready?
be
So if the 18 was like down at the base of it, it wouldn't work.
It wouldn't work. If the 18 were someplace else, if you you were gonna find the area of this triangle, you would need that angle. If you were gonna do it that way, if you were gonna use that formula, you would need that angle. So you would have to do some of the stuff Victoria did to find that angle. Because whatever angle you use must be between the two sides that you're using. Okay? Now, let's look at this problem. Find the area of a regular octagon inscribed in a circle with a radius of 10. Now you are thinking to yourselves, oh my gosh, why did I come in this morning? How in the world? Well, let's take it one step at a time. Here's a circle. What is it? What's an octagon? 8 sides. Regular means all the sides and angles are the same. So when I draw these, I go ahead and I just make 8 marks as evenly spaced as I can on my circle, and then I just connect those marks. Then I have an octagon that is inscribed in a circle.
You know the radius is 10.
And I know the radius is 10. So remember, radius now, so these are all 10s. Those are all 10.
So
Tell me about these triangles, regardless of the way I drew them. They're all the same. So if I could find the area of one of them, times it by 8, I'd have my answer, right? So let's look at this one right here. I want the area of that triangle. Now, the coolest, easiest way to do this, not the only way, there's never just one way, but the coolest, easiest way would be to know this angle. Because I have 2 sides, and that would be the angle between them.
It's 45.
Why is it 45?
Because you take 360 divided by 8.
Because all the way around is 360, and there's 8 of them, and you already told me they're all the same. So the area of that triangle would be 1/2 10 times 10 times sine 45.
all times by 8. With brackets.
And then the area of the octagon would be 8 times the area of the triangle.
Yes.
So here we go. What seemed to be impossible has become easy. I got 282.84. What do you think? And if this had been 10 inches, then this would be inches squared. Wow. Awesome, huh?
That's beautiful.
Let me try another one. Now we're glad you came in. Look at all the fun stuff you are getting to do. Let's suppose now we want to find the area of this triangle. Okay, now listen. Nick's saying if I did the law of cosines to find, let's say, this angle, any angle, but I'll say that one, then I could do my area 1/2 side sine of that angle. All right, let's do it. What's that law of cosines going to look like if we just arbitrarily say we're going to find angle A? What's that going to look like?
12 squared
12 squared.
equals 10 squared plus 14 squared minus 10
Two.
2 times 14 cosine A.
Now, this is one that you might want to do in pieces because your variable is over here. I got 57.12, but I'll wait for you to confirm that for me. I want to make sure everybody can get that angle, because that's the law of cosines problem. When you subtract 296 and divide by -280, you're going to get a decimal. Remember, you have to second cosine, inverse cosine, or cosine that. Reagan, you get 57.12?
I did.
Quigley, you get 57.12? So what's the area of our triangle? 1/2 10 times 14 times sine 57.12. Now I need you to do me a quick favor. Do you still have the 57.12 number on your calculator, the whole thing?
Yeah.
Okay, here's what I want you to do. I want you to, don't type in 57.12, I want you to use your answer button, because I want an exact answer. So I want you to type 1/2 times 10 times 14 times sine answer. And you should have gotten 58.78775,383. You'll see why this is important to me in a minute. After you've gotten this number, I want you to type this in on your calculator. Multiply these four numbers together and hit square root. What happened? Oh my. Oh my. The area of the triangle can be found this way too. Remember I said there are lots of ways to find area? Here's another one. Where did those numbers come from? Magic. No, let me show you. What is the perimeter of the triangle? Now remember, you were given all three sides. This technique is only going to work if you have all three sides, okay? What's the perimeter?
36.
What's half of 36? That number right there is called the semi-perimeter. Half the perimeter. So that 18 came from taking the perimeter divided by 2. Now, 18 minus 10. 18 minus 12. 18 minus 14. Those numbers, the other three numbers, are simply the semi-perimeter minus the length of each side.
How do people find that?
This is called Hero's formula. It's actually been abbreviated. His name was Heron of Alexandria, because those Greek dudes were fascinated by trigonometry. And if you look up Hero's formula or Heron's formula and Google it, you'll see, you'll find the proof of it, or the, you know, the derivation of it. We're not going to go through it, but it's there. Okay? So, the next time, let's try this one. Find the area of a parallelogram with sides of 10 and 12 and whose longer diagonal is 13. You're going to crank this puppy out in about 2 seconds. We'll draw a picture of it. Everybody remember what a parallelogram is? Opposite sides parallel and congruent. There's your parallelogram. How many diagonals does a parallelogram have? Two. Do you see how one is shorter and one is longer? So it says the longer one is 13.
12.
Now we want to find the area of that parallelogram. But it's two triangles, right?
Yeah.
So if we can find the area of this triangle, which we should be able to do, we'll double it and have the area of the parallelogram. So here we go. What's my perimeter? Remember, you're doing the triangle. What's my perimeter? Half of 35 is?
17.5.
And I am not panicked about that. I have a calculator, for Pete's sake. So it's 17 and a half. Okay. What am I going to multiply that by? 7 and a half, 5 and a half, 4 and a half. Did you get 57.995? Or 56.995, I'm sorry, 56.995? Now double that. 113.99 is the area of the parallelogram. Now, here's the moral of the story. Do we have to have Hero's formula? No. You found the area of this triangle by doing the law of cosines and getting this angle, right? But what does Hero's formula do for us? Shortens it. You don't need to mess around with that. Just use the sides. If you have all three sides, use Hero's formula. If you have two sides and an included angle, do 1/2 side, sine. If you don't have either one of those things, then use your law sines or cosines to figure something out so that you can then have what you need to do the problem. Okay? All right. Well, we got a little ahead of the game because we are so incredibly fluent. Here is your homework. to do a couple more law signs problems.
Yeah, we can. Here we go.
And I'm gonna throw in. Here we go. No, not 13, 17. Okay, and what happens on Monday? Over? No, not area, there's no area on the quiz, it's the law signs and cosines.